Hi guys, I hope you are doing well. So in today's video, we will be going to see how to set up Karpenter on our Kubernetes cluster, and we will be going to use EKS. But before going for the demonstration, we need to understand what is Karpenter, why do we need it, and then we will see after that how to set up it. So if I tell you about the Karpenter, so Karpenter is generally it helps you to scaling your worker nodes. In short, we can say that. So if you have heard about scalings, so there are multiple types of scaling where you will be going to scale your pods with the help of HPA and BPA. But as you know, the pods are ultimately running on your worker nodes. So those worker nodes have limited specifications like CPU and memory. So if your pods are getting increased, you need to understand that the worker node should also be increased. To increase those worker nodes, either you can use managed node groups like AWS provides, or you can jump on Karpenter or any other open source tool like plus Autoscaler to Autoscale to increase the worker nodes. So that's why we need Karpenter, where we can understand, okay, now I need one more node, and as my pods are in pending state, so we have to create one more worker nodes. So in that point, Karpenter will do your job and you don't have to manually create your worker nodes. And whenever any worker nodes will be underutilized, it will also delete those nodes to save your cost. Let's understand the workflow, whatever we are going to do today's demonstration through one architecture. So I have created one architecture here. So this is my like AWS cloud. On that we have AWS Elastic Kubernetes service. So let's understand this workflow step by step. So first of all, I have Terraform code to configure EKS cluster, and that will be done through GitHub Actions. And then once you will trigger the GitHub Actions workflow, it will create your entire EKS cluster and other services that is required for this demonstration. Once you will do that, we will be going to create, we will be going to set up Karpenter from our side. I would say manually, because that is not automated for this demonstration. But once we will do that, you can see that we will have few pending pods, and with the help of Karpenter, we will be able to schedule those pods on our create new nodes created by Karpenter. So as I've told you that Karpenters helps us to create new worker nodes according to the requirements of the pods. And if you see EC2 node class and node pod, these are the YAMLs that uses like a template where it will create node claims, and then node claims provides this to Karpenter to create worker nodes. So I would say, in other words, I can simply say that EC2 node class and node tool is like contains the specifications of the EC2 machines, and then it will pass to node claims, and then node claims provide the same to Karpenter to create the machines with the same specifications. Okay, so this is the workflow we will be going to do. Okay. So let's move forward towards the demonstration. So first of all, we will be going to deploy our EKS cluster because it takes a lot of time. So this is my repository EKS Terraform GitHub Actions. So there you just have to click on that actions section and click on the Terraform button, and there you will see run workflow, and make sure that the branch you should select K8s GPT demo because it contains specifications related to public Kubernetes clusters. Like if you try to deploy the Kubernetes cluster from the master branch, this will create private Kubernetes cluster, and you may face some problem while accessing the Kubernetes cluster. Okay. So for this demonstration, just I use this branch, and the path of the TFWares file would be as it is, and just apply and then run the workflow. As soon as you will click on that workflow, you will see that the workflow has been triggered and the pipeline is started, and it will take, I would say, 20 to 15 minutes to complete, and like along with initializing and all those things. If you like don't know how to do that, so meanwhile we can go through the code where like I've written the Terraform scripts to create the services. So let's see what are the services that we have configured. So first of all, we have configured VPC, which is related to networking service, and along with that, I have configured all those other networking services required for this demonstration, like internet gateway, public subnet, private subnet, then a route table created and associated with the both types of subnets. And then we have also in net gateway, because we are using private subnet, so to provide the internet, we are using net gateway. Then we have also security groups for our EKS cluster. Then after that, I have created IAM roles for EKS cluster. This is one for EKS cluster. Then this role for EKS worker node, and it will have the policies like EKS worker node policies, EKS CNI policy, container registry, and so on. And in the end, we are creating our EKS cluster with the, as you can see in here, we have mentioned public subnet. So this would be our public cluster. We are also creating OpenID connector provider. Then there are few add-ons that we have added for our Kubernetes cluster. After that, we are going to create node group, in which there are two types of node groups. The first is on-demand node groups, and the second would be spot node groups to reduce the cost. So this is the Terraform scripts to do that. Now let's see where we have reached the workflow. So as you can see that I think it should be created few services, like few networking services for our demonstration. So meanwhile, we can complete our other prerequisites. So for that, I will create one Kubernetes access server where I will bootstrap my Kubernetes cluster from there. So I will just give a name with the Kubernetes access server. I will use Ubuntu image for this, and instance type would be 3.medium. I'll take care of the key pair as well. I will use the same VPC with the public subnet, and the autos and public IP should be enabled. And then I will select the security group. I'm good if I use the security group. Then the storage is fine. I don't have any issues with the storage. Then after that, I want to access my EC2 server through browser itself with SSM. So I will use this permission SSM instance managed code. Then after that, I will have to install few tools or utilities, I can say, like AWS CLI, Helm chart, and kubectl utility. So for that, I will use this script, and you will get this script from the description. So no need to worry about that. So this will install the unzip utility, because we have AWS CLI that needs unzip utility to unzip the AWS CLI zip, right? Zip file. And then after that, we will be going to install kubectl and then Helm chart. So I will just click on launch instance, and it will take again 2 to 3 minutes to deploy the machine. And I just okay, so the status check should be 3 out of 3, because we are also installing few utilities. So to ensure that each and everything has been installed, for that we will wait for 3 out of 3 status check, and also we will also wait for this Terraform action, and maybe in that time we will be able to see that our Kubernetes cluster has been deployed. So our cluster has been created and the worker nodes are getting created. But if I check the EC2 instance, so it is created and the status is 3 out of 3, which check pass, and I will use session manager to connect with the Kubernetes access server, and I will log in as the user. Then first of all, I will check all the three utilities whether they have installed or not. So I will just use the command -hyphen version. So as you can see the error, so yeah, it is installed. And I will check for Kubernetes kubectl utility as well. That is already installed. Then I will check Helm version. Yeah, so all three things have been installed. Now we will bootstrap our Kubernetes cluster, but the Kubernetes cluster needs access keys because as we are going to use it, right? As we are going to bootstrap, it needs access. So for that, I will run AWS configure command, and then I will get the access keys, copy and paste here, and I will provide the reason. The reason would be USC for me, and then I can see the CLI has been configured. Now I will bootstrap my Kubernetes cluster. The command would be AWS EKS update -config -name of the Kubernetes cluster. If I'm not wrong, the command would be is right, I guess. So yes, so here you can see that cluster has been bootstrapped. Now we'll see nodes, and you can see that one node is in the ready state and the other is not ready because it's getting created, as you can see. So yeah, maybe it will become ready within few seconds. Yeah, so both the nodes are in ready state. So our first step has been completed. Now we will move forward to the next thing where we will be going to install our Karpenter. But again, before installing that, we have 3 to 4 prerequisites we have to do. So in that, first of all, we have to do one thing. We need to get the name of our worker node that is attached to our again worker node. So first of all, we need to get the worker node role name that is attached to our EKS worker node. So for that, I will go to the IAM section. Then I will navigate to the roles. So the role name would be same. Just this is the name of my worker node role. Okay. So then after that, with this worker node command. So what are we going to do next is we have to set few environment variables to make it easy, like to make this demonstration easy. So these are the environment variables that we have to set. So let me just go through one by one. The first is Karpenter namespace. So we will be going to deploy our Karpenter deployments and all other resources in Karpenter namespace. Like we will be going to use different isolated namespace, which is Karpenter. Then the next thing would be Karpenter version. So I am using 1.6.0 version, which is, you can see this is the latest version of Karpenter. Then after that, this is my cluster name. And this is the region. Then we are using 1.33 Kubernetes cluster, which is again the latest version of Kubernetes. Then for AWS partition, it's AWS. Then I was talking about the EKS worker node role. So I pasted role name here. Then I'm getting the account ID through AWS CLI command. Then I'm getting the OIDC endpoint through this AWS CLI command. And in the last, I'm getting alias version. So alias version is nothing. It's just a AMI I'm getting for my Kubernetes worker nodes. So this way it will tell me the version compatible EKS worker node. So if I just click enter, it will take time, like that much time, take 5 to 10 seconds. And then you can just validate through cluster name. Yeah, it's working. If you try anything else, like Karpenter mini space, or let's try with uh, version. So yes, the version is it's working fine, right? So our this step has been completed. Now the next thing is we have to do is we have to create the IAM instance profile. Now IAM instance profile for what? So let me tell you. So as you can see, this is the worker node role we have created. So the role has been created, but we did not create instance profile ARM. Okay, like we did not create instance profile for this worker nodes, and both the things are different because instance profile will help you to work with server levels like EC2 level. So maybe you might say that among the instance profile ARM we are able to see. So it means that instance profile is configured. No, it's not, because and if you see the random suffix of instance profile, it means that AWS generated it from their side and it is not created by us. So for that we have to create our own IAM instance profile for this role. And once we will create the IAM instance profile from our side, you will see that the name would be changed whatever we will use. Okay, so I will use this command. So in this there are two commands here. The first command will create instance profile with this name 4467 in the last, and then we will use the one more command in which we will add the role to that instance profile that we have created in the first command. Okay, as soon as I enter, we will say that it created the instance profile and the role also associated with the instance profile name. So to validate, you can just refresh it and you will be able to see that random numbers would be gone and our new numbers, like our new name, would be there. Yes. So you can see here the name of the role would be same as instance profile. Okay. So this step has been completed. Now we will jump on to the next one. Now we have to create SQS for our Karpenter. Now what, like, why do we need SQS? So let's go to the architecture again. As you can see that there are two logos of AWS, Event Bridge and SQS. Maybe it's not clear, but I hope you are able to understand the text. So the point is that what are the spot instances? Like the SQS will be going to use for spot instances. And as you know, spot instances are for temporary purposes and it is not good for critical loads. But you can make it more better for critical workloads. How you can do that? So whenever, like, the main disadvantage of spot instances are they can terminate it anytime. And as they can terminate it anytime, the existing workload can be deleted anytime. For that, what you can do, AWS sends a message or kind of a notification to Event Bridge that I'm going to delete this spot instance in next 2 minutes. So as Event Bridge will get the message, we will be going to use SQS, which will take the message from the Event Bridge, and then SQS will, or Karpenter will pull the message from the SQS. And as soon as it will get the message that, okay, the particular worker node is getting deleted, like the spot instance is getting deleted, Karpenter will drain that node, which means that it will remove the nodes. The Karpenter will remove the existing pod from that spot instance or worker node to the new worker node or existing worker node. This way, it will help us to achieve zero downtime and we will be able to gracefully schedule the pods to another nodes without getting interrupted, right? So that's why we have to create SQS in which it will get the message related to spot instances interruption events. Okay. So for that, again, I'll go to the systems. I'll go to the EC2 server and I will run this command. Now this command will create queue. Okay, so let's see right now, do we have any queue or not? Let me just check it. I think yes. So we don't have any queue right now. So I will just, and you can see the queue name is from the cluster name. And you can see that this is a queue URL. So I am expecting that queue has been created. Okay, let's maybe takes time. Yeah. So I don't know why the first command didn't work, but yes, from the second command, we are able to see our queue. And then, yeah, so SQS part is completed. Now we will have to create the next thing, which is Karpenter controller node. Now, what is it? So as you know that Karpenter will be going to create worker nodes. So it needs a permission because it will use AWS APIs, right? Where it will use EC2 instances and a lot of things to create worker. So for that, Karpenter controller needs a role, it- and along with that, it needs a permission for that. So for that, we will be going to create one Karpenter controller node, and in that role, we will be going to provide few permissions related to EC2, IAM instance profile, and SQL on and SQS. I'm just telling you from the high overview. You can also check the policies and roles from the article itself. So let's try to create the role. So first of all, before creating the role, we will render the role. Like as you know that roles needs a trust policy. So we will be going to render the trust policy. As you can see that I'm using AWS account ID. Like I'm using placeholder. I'm using variables, and in that variables, we will have our values that we have set in the earlier steps where we were exporting the environment variables, right? So if you just see if you just get this file controller trust policy, you will see the different things over here. Can you see that the Karpenter namespace has been replaced with Karpenter, the OADC endpoint has been replaced with the actual endpoint, right? So this is the trust policy. Now we will be going to create role, and I will run the command to create the role. The role name would be Karpenter controller node hyphen cluster name. So yes, the role has been created. Again, let me go to the role section and let's check whether the role Karpenter controller node. So yes, the role is there. And as we did not add any policies, so we don't have any policy, okay? And you can see this is the trust relationship that we have created. Okay, so now we will be going to create policy. So before that, we will be going to render the policy, and it's a big policy. So it's fine if you're not able to understand the policy. So yes, again, the same thing. Let's try to see the policy, whether it's correct or not. So this is a controller policy, and you can see here, the policy looks fine to me. If I show you, see, these are the SSM and EC2 permissions, pricing permissions as well. It have then wants to have terminate instances. Then IAM pass role for the cluster name, cluster worker node role, right? So there are a lot of permissions it needs related to EKS cluster as well. And you can see SQS access to also have. As we have rendered the policy, now we will be going to create the policy for that role. I will just hit this command, and as soon as you hit the command, I will just refresh it, and I'm expecting the policy should be added. So yes, the policy is here. We just try to expand it. Should be same as it was, as we have seen in the terminal. Yes, it is. Okay, so the policy has been created. So now the next thing is we have to add the tags. So now what is it? Like, what are the tags? So tags, like first of all, let me tell you, we will be going to add tags on security groups and subnets. Okay, so again, why do we need it? So let me tell you, it will like Karpenter needs to understand, okay, I need to use which subnet and which security group to configure new worker nodes. So let's say as Karpenter needs to create a new worker nodes, it's like few information. So like it can't create anything anywhere. It needs to be specific. So to be specific, Karpenter will be going to add tags. So with the help of tag, it will add the tag over there at the particular subnet, and then whenever it will be going to create worker node, it will use that tag to identify like which subnet it needs to use to create worker nodes. And same with the security group. So we will be going to see how it will work. So first of all, we will be going to add tag on our subnets. So as you know that we are using public subnet. So let me show you before applying the subnets. I will go to the VPC section. There you will see 2122 VPCs. So I will use my VPC that I'm using right now, which is AP BDM VPC. And then I will see public subnets. Any public subnet you can see right now, I'm using public subnet 3. Here you can see I have only 4 tags. Okay. Just to keep remind about this, that I have 4 tags only. Now once I will run this command, now let me tell you what this command will do. So first of all, this is a for loop initial, and in the for loop, it will get the node group. Okay, it will list the node group with the help of AWS EKS list node group from that particular cluster. Once it will get the node group, okay, it will tag that, and the tag would be carpenter.sh/discovery. Again, it is for discovery, that it wants to know that, okay, on which subnet the tag is added, like the tag I have added, right? Carpenter wants to know. Once it will understand that, once it will know that, okay, this is the tag that I have added to that particular subnet, I will use that. Then after that, hyphen resources. In that, you will see that it will describe node group, and in that, while describing node group, it is querying to node group dot subnets. It will fetch the subnets. Okay. So I will just hit enter, and once you will like hit enter, it will take like 5 to 10 seconds, and then you can go to your VPC section. Just remember public net subnet 3 right now. Earlier we had 4 tags. Now we have 5 tags, and the tag would be this carpenter.sh and the cluster node. If I show you other public subnet, not private, okay? So it will also contain the same carpenter.sh and the same thing with public.node. Okay, now if you try to see private subnets, you won't be able to see because we did not use private subnets in our EKS node groups. So that's why the tag is not added to that subnets. Now the same way we have to add the tag to our security group that is using for the same worker nodes. So I will just hit the command and will show you the result directly. So if you see, just to go to the security groups for the same VPC, and there is a one security group named EKS cluster as like the big name, and you will see the tag, and see here the tag is already added for carpenter.sh after running this command. Okay, tag work has been completed. Now we are just near to deploy our carpenter. So now we will be going to generate one YAML file to deploy carpenter. So let me show you the command. There are 2 commands. The first is helm template carpenter. In this is the repository. OCI repository is there where the carpenter repository is present, and the version, as you can see, the version is coming from the environment variable namespace as well. Okay. Then the second command was, it is setting the things at the values.yaml. Okay. So like the cluster name is setting to the cluster name. Then the interruption queue, I've told you about SQS, right? So the SQS is using here in that interruption queue. Then the service account annotation, I've told you about Carpenter controller node that is going to use by Carpenter. So this is the Carpenter controller node. Okay, and the placeholder you can see. Then after that, these are the request and limits for the Helm chart. And in the end, you will see the all the configurations will come in the carpenter.yaml. You just need to hit, and you will see the first of all the repository is fetched with the version 1.6.0. And if you just list down the files, you will see the carpenter.yaml is present. As we have got the files to deploy our Helm chart, we have to make just one change to deploy our Helm chart, which is affinity rules. Okay, so if I just added the carpenter.yaml, first of all, I will just open the to show the lines. Okay, then after that, I will search for affinity. As you can see, the affinity here you can see it. Okay, so this is at 406 line, the affinity rule. Then after that, we have to add one more rule, and the rule would be the node group. Okay, so it will match with the node group name, and this is the node group. Okay, and once you made the changes, just hit escape button and column save the file. And as we have made the changes to our carpenter.yaml file, we are ready to deploy it. But before that, we have to do one change, which is we will be going to create one separate namespace, which is Karpenter. So let me check whether the namespace has been created or not. You can see the Karpenter namespace has been created. So now the ultimate last step before installing the Helm chart is to deploy the CRDs. Okay. So now we will deploy the CRDs. Just hit enter, and you will see that the CRDs has been created, and I will just check whether the CRDs has been created or not, whether they have been deployed or not. So you just write the command tuple get CRDs, and here you can see at the second point EC to node class is present, then node claims and node pools. So our all three CRDs are available, and now we are ready to deploy our Karpenter. For that, I will just run kubectl apply -f carpenter.yaml file, and you will see it will create a lot of resources like deployment service, role binding, service account, 3DBs and all. So as soon as you will deploy it, just do one thing, just see the pods. Just see the pods, Karpenter in the particular namespace, and you will be able to see that your both pods are up and running. And if you see the logs of your application, like maybe if something goes wrong, you can check. It will show you the errors, right? So it is saying that, okay, starting workers, controller group, and it's taking time again because the leader, it takes time to acquire leader, right? So that's fine. So this is like till now it's working fine. So we don't need to see more logs for now because it's time for testing. We want to like test our application, but before testing, we have to create our own notebook and EC2 node class. Maybe you are confused in one thing, which is that we have already deployed our CRDs. So maybe the node pools and EC2 node class already created. Yeah, that is deployed. The CRD is deployed. So with the help of those CRDs, you can create your own node pool, right? So that's why the specifications of our machines, we will be going to set from our side, not Karpenter will do that, right? So for that, we will use our own node pool and EC2 node class. Let me tell you, node claims will be created from Karpenter with the help of node pools and EC2 node class. So now I will just run this command. As you can see, this is the node pool in the default namespace. And you can see the architecture AMD 64 series, the operating system is Linux, the capacity type is Spot, instance category is CMR, then instance generation is there. Then if you see the node class, so node class will have also the EC2 informations like subnet ID and all. So As soon as you will hit the button, you will see that the NodePool and EC2 Node Plus would be created. Let's list all those things. So, okay, the NodePool is created. Yes, so I can confirm from one thing, which is both are in ready state, like it should be true. The ready state should be true. So if both are in true state, so it means that your NodePool and EC2 Node Plus is being created properly. Okay, as we have done our last thing, now we are ready to scale our application and we will try to test this, whether Karpenter is working fine or not by scaling or creating more worker nodes or not. Okay. So first of all, we will create one deployment with replicas 200 of small Nginx application. I will just run this, and as soon as you will hit, you just need to see Kubernetes get pods, and you will see a lot of pending pods are there because first of all, it will take time as well, and ways to do just run kubectl get deploy, and you will see that 17 out of 200 pods are available right now, and it would be increasing if I check the node claims now. Okay. So you will see node claims, right? The Redis is unknown because it is taking time, it's a little bit. The capacity type of this is spot. This is the type of instance that created by Karpenter because we have set it in the EC2 node class, right? And if I just run it the same thing again, and yes, the node has been created successfully, as you can see. And if I run the kubectl get deploy command, all the pods should be up and running. Yeah, again 56 out of 200. So it will be 200 out of 200 soon because our worker node is created. You just list the nodes, so you will see that earlier we had two nodes, now we have third node created 48 seconds ago. And if I check the deployer, so you can see 152 out of 200 pods are available. Again, let's check. So this way you can handle the traffic if traffic is increasing in your application. So with the help of HPA or VPA, it will create more pods or it will increase the size of the existing pod. And as the worker nodes will be filled with those pods or with those CPU and memory, so Karpenter will help us to create more nodes. This way we can achieve the auto scaling from the both way, and we can try to achieve the like no downtime or zero downtime. So if I try to check again, and you can see that we have deployed 200 out of 200 pods are running. So let's try to just increase the replica sets from 200 to 300. So we can understand, okay, it should create one more worker node. So I will just do the something. Kubectl get deploy. If you see 212 pods are there because maybe there were some resource available on the existing pod. But if you just run kubectl get node claims, you will see that one more node present. Okay. Yes. So because it needs one more node to schedule all those pending pods. So let's see how much time it takes. It won't take much time, but again, you need to understand. So yes, the second node is up and running. Now the pods are scheduling on the new worker node. Okay, now let's check the deployment. Yeah, 280 out of 300. Yeah, it's 294. So you have seen that like deploying the application from 0 to 200, then 200, 300. It didn't take much time. So you will be able to see 300 out of 300 pods are running. So this is about scaling up. Now in the end, we will be going to see scaling down the worker nodes. So as we have running 300 pods of a Nginx application, I will just down it to 5 replicas. And as soon as I do it, you will see 300 out of 5. And if we see the nodes right now, we have around 4 nodes running, and the 2 nodes are already running, which is minimum. So the other 2 nodes should be deleted. Okay. So if I run, first of all, deploy again, first of all, the pod should be deleted. Okay. So you can see that 295 pod has been deleted, and 5 out of 5 is in the ready state. Now it takes some time to delete the nodes, and also you can use node cleans command. And as per my experience, it takes around 2 to 3 minutes to delete one node. And then, so I just run one command to check, to validate whether scaling down is working or not. Now you can see that there are only 3 nodes running, and if I list down the node claims, it will show me one node claim only. Yeah, so as you can see, the last node also got deleted, and if you again the node claims command, it will be able to see nothing, no resources found. So like the scaling down is also working as expected. And so that is it for the today's video. I hope you have learned something from this video. Before leaving this video, I would ask you to destroy your infrastructure, whatever it was running cloud, because it will generate you a lot of cost. So okay, I'll do the same, so you can also follow the same thing. First of all, I will just terminate this Kubernetes access server. Okay, then after that, I will delete this queue. Delete this queue. As you can understand that spot instance, the queue won't work here in this demo because spot instance interruption is not in our hand. Then after that, you have to delete that controller role. And then after that, if you have created the Kubernetes cluster using this workflow, you just have to do one thing, which is uh, go to the actions section, click on Terraform, run workflow, use create cpt branch, and destroy. And it will take again 15 to 20 minutes to destroy the infrastructure. So yeah, that's it for the video. Thank you.